Good morning, my YouTube viewers. In this video, what we're going to discuss is estimation. So estimation is a central concept in the field of probability and statistics, playing a critical role in making inferences about population parameters based on sample data. Estimation involves using sample data to infer the characteristics of a larger population. And so what we're going to do is we're going to go over a sample program to help you to gain greater understanding of estimation. And so before this program is going to be written in Python, and we're going to import 3 libraries into that program so that it can be executed. So we're going to import NumPy as NP, which is the numerical library. We're going to import scipy.stats as stats, which is the statistical module in the SciPy library, and SciPy is a scientific library. And we're going to import matplotlib.pyplot as PLT, which is the visualization library. So after we have imported our libraries, what we're going to do is we're going to generate some sample data. So the first thing that we want to do is we want to set our seed. And so when you set your seed, what that means is every time you run the program, it initializes to the same values. So you set the seed by typing np.random.seed, and then you can put any number you want inside the brackets. So the sample size is going to be 40. Population mean is going to be 170. Population standard deviation is going to be 10. And the sample data is going to be np.random.normal brackets. Log is your population mean, comma, scale is your population standard deviation, comma, sample size is your sample size. And then after we have generated our sample data, what we're going to do is we're going to do point estimation. So sample mean equals np.mean brackets sample data. So that's the point estimate of the population mean. Now we're going to do interval estimation at a 95% confidence interval. Confidence level equals 0.95. Sample standard deviation equals np.std brackets sample data, comma, DDOF equals 1. So your DDOF is your degree of freedom. Standard error equals sample standard deviation divided by the square root of the sample size. And then your degrees of freedom equals sample size minus 1. So if your sample size is 40, your degree of freedom is going to be 39. So now we calculate our confidence interval using a t-distribution. Confidence interval equals stats.t.interval brackets confidence level, which is 95%, comma, degrees of freedom, which is 39, comma, log, which is sample mean, comma, scale equals standard error. And then we're going to print the results. So we're going to print the point estimate of the sample mean and the 95% confidence interval. So the point estimate is 167.81 when you had a population mean of 170. You've got a sample mean of 167.81, and 95% confidence interval is 164.77 to 170.86. So you can see here that the population mean and the sample mean are not the same, because the population mean is 170 and the sample mean is 167.81. Because you can see right here, we set our population mean to 170. So now we're going to visualize it using Matplotlib. So we're going to make a histogram. So we're going to plt.figure brackets fig size equals 6, 4, and then we're going to create the histogram. plt.hist bracket sample data, comma, bins equals 10, comma, color equals light blue, comma, edge color equals black, comma, alpha equals 0.7, comma, label equals sample data. And then we're going to put some vertical lines in the histogram. So plt.axvline bracket sample mean, comma, color equals blue, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals sample mean. And then plt.axvline brackets confidence interval 0, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals lower bound confidence interval 0. Then you have plt.axvline brackets confidence level interval 1, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals upper band confidence interval 1. So now we add titles and labels to our chart. So the title is Point and Interval Estimate of Population Mean. The value, the X label is the value of the height in centimeters. The Y label is the frequency. You get a legend, you get a grid, and we're going to show the chart. So now we have point and interval estimate of population mean. So sample data is your light blue columns. Sample mean is in the center and it's dark blue or royal blue. Lower bound is in the green and upper bound is in the red. So your sample mean is 167.81. And it goes from 164.77 being the lower bound to 170.86 being the upper bound. But you can see that the population mean of 170 is not the same as the sample mean. So this concludes our video on point and interval estimation. The next one is going to be on another subject to do with estimation. So I hope you decide to watch it.